Welcome back for part 2 of our lecture. Now we're going to be talking about different ways that we can name the same polar coordinate. So we talked a lot about coterminal angles when we were going over the unit circle, and that's where this is really going to come back. So let's say that we have a point P with polar coordinates r comma theta. Any other polar coordinate of P must be of the form r comma theta plus 2 pi n. So remember, this is just one revolution of the circle. Okay, so this would be, since we have the same r, we're staying on that same ring, and then we're just going around one more time. Or it has the coordinates negative r, and then theta plus 2n plus 1 times pi. So this is your odd multiples of pi. So this is taking you, remember when we have negative r, that is on the line of our angle theta plus pi. So now we are going to be going from that angle where we added theta plus pi and then going around a circle for that one. So don't worry, we're going to do an example. It'll make more sense. So working on this example here, we want to find all polar coordinates of the point 3 comma pi over 3. So we're going to call this point P, and I'm going to draw it over here. So on our axis system, okay, we know that we are going out to pi over 3, so it's going to be somewhere around here, and then 1, 2, 3. So this is our point P. So it has a radius of 3, and then this angle right here is going to be theta, or not theta, we're going to call that pi over 3 because we know what it is. And that's going to make our life a lot easier. So pi over 3 is right here. So that's telling us that, all right, we're going from our center, we're going around an angle of pi over 3, and then we're going out 3 from the center. But according to this, when we have P is equal to 3 comma pi over 3, we can do plus 2 pi n. So what happens if n is equal to negative 1? When n is equal to negative 1, we get 3 comma pi over 3 minus 2 pi, and that gives us the point 3 comma negative 5 pi over 3. So looking at this point, remember we start by looking at our angle. So we're starting on that positive x-axis, but since it's a negative angle, we're going to be going clockwise, and we're going to be going clockwise to negative pi over 3, which just so happens to be the coterminal angle of pi over 3. And then we're still on that same rung because remember this radius of 3 goes all the way around. It's not a bad circle if I do say so myself. Pretty proud of that. So now if n equals 1, because if n equals 0, we just have 3 pi over 3. Not exciting. That's the point that we already started with. So if n equals 1, then we will have 3 comma pi over 3 plus 2 pi, which is equal to 3 comma 7 pi over 3. So then that's the same thing. 7 pi over 3, 6 pi over 3 is one revolution. That's 2 pi. So we go one time around, and then we go an extra pi over 3, and that brings us right back to that point right there. And then just for kicks and gigs, if n is equal to 2, then we have 3 comma pi over 3 plus 4 pi, which would be equal to 3 comma 13 pi over 3. And same thing as before, 12 pi over 3 is going to be 2 revolutions around the circle, starting from the x-axis, and then we go that extra pi over 3. So now is where it gets a little bit trickier because we're adding in that negative angle, or that negative radius now, okay? So remember, let's say that this point right here has an angle of pi over 3 plus pi, so 4 pi over 3. If we have this point right here, and we have a negative radius on that point, so if we have a point that theta value is 4 pi over 3 and it has a radius of negative r, then it's actually going to be along this point here because we go along the terminal side, this back side here. So when we have a radius of negative 3, then we need to have our pi over 3 plus 2n plus 1 pi. So let's say that n is equal to negative 1. If n is equal to negative 1, then our point becomes negative 3, comma, pi over 3 minus pi, which gives us the point negative 3, negative 2 pi over 3. So this would be saying, all right, we find our angle of negative 2 pi over 3 first, so we're going clockwise around the unit circle. We end up at this point here, and then since we have a radius measure of negative 3, we go out here, and that brings us to point P. So this works. If n equals 0, then we would have negative 3, comma, pi over 3 plus pi, and that would give us negative 3, comma, 4 pi over 3. So same thing, we're going around to 4 pi over 3, and then since we have a negative radius, we start at the origin and we go off the back of that angle there, and that brings us to our point P. So this one here is going to be talking about within 1 revolution of the unit circle. So this is saying that we are within theta values of 0 to 2 pi. So we have our point P that has a radius of 5 and a theta value of negative 3 pi over 4. So let's sketch this out real quick. If we are in our polar coordinate system, we're starting here, we're going negative 3 pi over 4. So pi over 4 is right here, 2 pi over 4, 3 pi over 4, and then we're going to be going out 1, 2, 3, 4, 5. Ooh, that was a rough line. That's okay. All right, so this is our point P, and we want to find different ways that we can represent that point P in polar coordinates. So one of them is instead of having negative 3 pi over 4, so this angle right here is negative 3 pi over 4, what if we found its positive counterpart? So instead of measuring clockwise, we measure counterclockwise. So going around, our coterminal angle for that is 5 pi over 4. So this angle right here is 5 pi over 4. And then since we're still going out in the positive radius direction, our point is 5 pi over 4. So there's no other way that we can get to this point while keeping our angles within the unit circle. So now we need to start looking at having a negative radius. So if we have a radius of negative 5, then its angle measurement right here is going to be pi over 4. So if we go here, we have a angle measure of pi over 4, and then we have a radius of negative 5. We're going to be going off of this angle right here, down to p. So another way to represent that point would be -5, comma, pi over 4. And then our last way to represent that would be if we have -7 pi over 4. So if we go -7 pi over 4, that's going to bring us here. And then, so going from here all the way around, this gives us -7 pi over 4. And then again, we're going backwards 5. So -5, comma, -7 pi over 4. And I'm realizing that I misspoke on this. We don't want it to go from 0 to 2 pi. We want it to go from -2 pi to 2 pi. Because we want, so one revolution just means that we're not looping around multiple times. So in this example up here, when we did the example of 4 pi, we went around the unit circle once and then around again. And then same here, even with 2 pi, we went around and then went back up. So here is just none of these angles cross the x-axis again. So that is finding multiple points, and I have one more little short part of the lecture that we have, so stay tuned and hop on to the next video.